Hey there, welcome to my YouTube channel. This is Unit 1 Electrostatics, and the topic of discussion for today is Gauss Theorem or Gauss Law in electrostatics. This is one of the most important topics in class 12th, and we may get the very straightforward question, that is state and prove Gauss Theorem. So let us discuss the statement of the Gauss theorem. According to the first statement, the total electric flux coming out of a closed surface is equal to 1 upon epsilon naught times. Here times indicates that multiply. So 1 upon epsilon naught times the charge enclosed by the closed surface. So according to the first statement, what we have, the total flux, it is about the flux, so we always indicate flux with phi. So total flux which is coming out of closed surface is equal to 1 upon epsilon naught, and here I have written the word times, that is 1 upon epsilon naught multiplied by the charge enclosed by the closed surface. Let us say this is a closed surface and the plus q charge is enclosed in this closed surface, then phi is equals to 1 upon epsilon naught multiplied by q, that is the charge which is lying inside the closed surface. So we can write it as phi is equal to q upon epsilon naught, and this is the expression of the flux which we have found only with the help of Gauss theorem. We have not proved the Gauss theorem, but as per that statement of the Gauss theorem, we have flux coming out of the closed surface is equals to 1 upon epsilon naught times the charge enclosed by the closed surface. And as per the second definition of Gauss theorem, we are having the surface integral of electric field over a closed surface is equal to 1 upon epsilon naught times the charge enclosed by the closed surface. That is, if we will take a surface integral, but we will take the surface integral of electric field intensity, that is E dot ds, and when we will solve this surface integral, again as per the statement of Gauss theorem, we will have surface integral of electric field is equal to q upon epsilon naught, but this surface should be a closed surface. Therefore, combining these two equations, we have phi is equal to closed integral E dot ds. We will put a symbol closed because surface to be considered is closed, is equal to q upon epsilon naught. So this is the expression of the flux coming out of the surface, and we need to prove this expression, and hence we will prove the Gauss theorem that whatever kind of the closed surface we have considered, then the flux is always q upon epsilon naught. Now, before proving this Gauss theorem, the first thing we are going to do is to describe the Gaussian surface. It is important to know what the Gaussian surface is. First of all, the main point of Gaussian surface is that it is a hypothetical closed surface. I will write it as hypothetical closed surface. That means it is an imaginary surface. By the term hypothetical, I mean a closed surface, that is imaginary closed surface. So a hypothetical closed surface chosen to calculate the surface integral of electric field is called a Gaussian surface. Any surface which is closed surface and is imaginary as well, which is just considered so that we must be able to calculate the surface integral of electric field, and that kind of surface is called a Gaussian surface. So we do not need any real physical surface, so it does not need to be a real surface. That means we just have to imagine. We do not want any real surface. Any imaginary surface which is closed will be acting as a Gaussian surface. So we can say it not need to be a real physical surface such as the surface of a solid body. And the third part which we need to know about the Gaussian surface is that it could be of any shape or of any size. So Our Gaussian surface is a kind of surface which could be of any shape or any size, but we will always consider that kind of Gaussian surface over which we can easily take the surface integral of electric field. So if we will take any arbitrary surface, something like this, in this case I will not be able to calculate the surface integral of this surface. But if I will have to calculate the surface integral of this sphere, so surface area of sphere is 4 pi r square, then it is easier to calculate the surface integral. Therefore, we will consider only that geometrical Gaussian surface over which it becomes easy to calculate the surface integral. Last, about the Gaussian surface is, it is always a closed surface. This is very important as well. It always needs to be a closed surface. So these are some of the points which we should know beforehand about the Gaussian surface, because if we want to prove the Gauss theorem, we need to know all these properties of the Gaussian surface. Now, as we are going to prove the Gauss theorem, first of all, we will give the heading that proof of Gauss theorem. So when we will have to do a proof, we will indicate some of the points. The first point is, let us say we are having a plus q charge lying over this point, and now we need a Gaussian surface. Before needing a Gaussian surface, let us recall, because of plus q charge, the electric field will be acting in the outward direction such that it will leave any surface with the with making an angle of 90 degree. So every time electric field move out of a charge, it leaves the surface of a charged body perpendicularly. So let us say electric field is acting in the outward direction over here, and we are considering a Gaussian surface. Let us say this is our Gaussian surface, and I have considered over here a Gaussian surface to be a spherical one. So this is my Gaussian surface. Let us say that this Gaussian surface is having a radius r, and I want to represent the point of observation over here as P. So this is my point of observation. Now the radius is taken as r, so I will represent the distance of point P as r vector from the center of the Gaussian surface. Now electric field is acting in the outward direction, so I will mark it as E vector, and electric field is acting along the radius. So it is acting in the outward direction but is acting along the length of the radius. So r cap can indicate the direction of electric field intensity. Now I need to consider a small surface area, and area vector I have taken at point P an area vector. And what is area vector? Area vector is a vector which is pointing away from the area and acting perpendicular to the area. So this vector which I have taken in gray color, so this vector is area vector. I will mark it as ds vector because I have considered a very small area of the sphere of radius r. This is a Gaussian sphere, and over the Gaussian sphere I have considered a very small area ds, and for ds area I have considered a area vector ds vector. And what is area vector? Any vector pointing away from the given area and leaving the surface normally is called area vector. So I will mark its direction as per n cap. Now electric field is leaving the surface perpendicularly, and area vector is also acting normally with this surface area. So both these vectors, E vector and ds vector, are leaving the same surface perpendicularly. Therefore the angle between E vector and ds vector is 0 degree. I will mark it as 0 degree. First of all, I need to write down the value of electric field intensity in vector form, and we know electric field intensity is equals to 1 upon 4 pi epsilon naught q upon r square, And as I have put the vector symbol over here, so I need the direction, and direction will be indicated with r cap. So this is my equation number 1. And now we need to calculate the closed integral E dot ds. So we already know this thing from the definition of electric flux, that phi is equals to closed integral E dot ds. Now here we have E vector and ds vector, because ds vector is taken as a area vector. Therefore we can write it as closed integral, substituting the value before substituting the value of E vector dot ds vector, I will just solve it as it is equals to E ds cos 0, because E vector is leaving the surface normally, ds vector is leaving the surface normally, both the vectors are leaving the surface normally. Therefore both these vectors are parallel to each other. Therefore we have angle between them 0 degree. Therefore we have phi is equals to closed integral E ds, because cos 0 is 1. So we have last expression, phi is equals to closed integral E dot eds, which is our equation number 2. Now we need to substitute the value over here. So when we will substitute the value closed integral E ds, we know the value of E is 1 upon 4 pi epsilon naught q upon r square, and I will write r cap, because if I will not solve it in this form, I will just not eliminate dot over here, then I can just write r cap dot, and now substituting the value of ds vector, I can write it as ds n cap. Now ds vector is represented, but in terms of n cap, how we can represent it as ds vector is equals to n cap ds, that is n cap is representing a direction unit vector which is adding a direction to the area ds, so it will become area vector. Now we have phi is equals to closed integral eds is equal to closed integral 1 upon 4 pi epsilon naught q ds upon r square r cap dot n cap. Again, if we will write it in this way, then again r cap is acting along this direction of electric field intensity, n cap is also acting along the same direction, such that r cap and n cap are leaving the surfaces normally. Therefore again the angle between r cap and n cap is 0 degree. Therefore I can write it as 1 cos 0, because unit vector has a magnitude 1, n cap is again a unit vector, it has magnitude 1, but both are parallel vectors. Therefore theta in between them is 0 and cos 0 is 1, and I have just substituted 1 multiplied by anything is anything. So we have the final value, phi is equals to closed integral E vector dot ds vector is equals to 1 upon 4 pi epsilon naught r square q taken out of integral, and we are left with closed integral ds. And now this closed integral is taken for the surface which is taken spherical. Therefore we have phi is equals to closed integral E vector dot ds vector, from where we have started, is equal to q upon 4 pi epsilon naught r square, and we know surface area for sphere is 4 pi r square. Therefore cancelling out 4 pi r square and r square, we are only left with phi is equals to closed integral E dot ds is equal to q upon epsilon naught, which is the Gauss theorem. And we did this same expression when we write the statement of the Gauss theorem. So I hope you have understood Gauss theorem, and if you have understood, then do not forget to press like, subscribe and bell icon.